Cool beans. Copy, pasty. Cool. Oh, brr. Hey, Matt, how are you? What's new? What's exciting? Nothing, huh? Oh, there we go. Oh, yeah? What are you playing? Yeah, I was on the Steam store the other day because I beat Cyberpunk, and then I revisited some old games. I tried to get another playthrough of Red Dead 2 in, but, you know, I got to a certain point and I was just like, nah, I'm good. So, I'm kind of curious as to what's out there. I really wanted to play, what is it, Ghosts of Tsushima. Oh, okay, yeah, Resident Evil. I think I played the first and the second one. I never played any of the ones after that. But I don't have a PlayStation, so, and it's not out on PC, so it's kind of, you know, I'll wait for it, I guess. Actually, after our discussion last week, I was thinking there's some older games out there that I never played all the way through. Like I never played Skyrim all the way through. I don't know if I want to commit to that. So yeah, that's what I hear. I hear Ghost is really, really good. And, you know, like, so I'm kind of a history nerd for that period of Japan, too. Actually studied it in college. Got to the point in time where my professor was like, well, you need to go learn Japanese if you want to do any more with this. Yeah, I'm thinking I might do Skyrim. I don't know. It's still like $30 on this, or like $40 on the Steam store, so usually when games are old like that and they still command that kind of price, they're usually worth it. It's just one that I missed. So, yeah, I don't know how much time I want to dedicate to it. So that's a good point. We're going to have to see whether or not I want to do that. I don't know. So, theoretically, I should be working on my own schoolwork and yeah, Dr. Gilbreth and I are doing some research and stuff, so that's keeping me busy. But, you know, still, it's all right. Yeah, actually, you know what? Maybe I'll do that. Maybe I'll put it on my wish list, and then they'll ping me with an offer. That used to be the hack on Steam, where if you put a bunch of stuff on your list, and if it sat there for, you know, sometimes just a couple days, but sometimes a couple months, eventually they would stitch something together for you, and then you can snag it real cheap. I've never seen it show up on live, so yeah, I've never seen it show up there. Or I don't know. Maybe I haven't looked in a while, so we'll have to see. So because that's a screaming deal. I love that. I love Xbox Live. So. Yeah, oh yeah. I remember the Game of the Year bundle. Yeah. Fallout 4, man, I bought that as soon as it came out. I paid full-blown retail for that thing. I've been waiting for it, so they'll get me on the next Dragon Age, too, whenever that comes out. Hey, Lexi, how are you? Yeah, we'll just have to see. I don't know. I'll get into something. I always find trouble to get into. So if not, it might be time for another Minecraft binge. So, because I return to that game about every other year or so. We'll just go hack away at the wilderness. All right, but that's okay. All right, here we go. So welcome back, Stats. Let's dive into our pie a little bit today. Need a trivia topic. All right, and so yeah, like I said, I just started playing Red Dead 2 again, and I mean I've already got a playthrough and a half done on it, and I mean it's like a 60-plus-hour game. And I mean, any game like that that lets me wander around, I mean, oh my gosh, you can just instantaneously double the amount of time that I'm going to spend in it. I think I was one of the few people who got the full 100% on the original Red Dead, and I think Red Dead 2, I got it up to over 90. But there were a couple challenges I just couldn't do them. It wasn't good enough. Online, no, I don't play well with others, man. So, my days in the Call of Duty army are over. So I did 7 tours. I'm good. With the online stuff. I appreciate the sentiment, though. Anyway. Yeah, we need a trivia topic today, and so whatever you got in mind, throw something up there. We just did soccer in the previous class. So anything, no matter how esoteric it is, because we are at the point in time in the semester where a few people do drop out or are just disengaged for a little while. Those of you who are here, I'm glad you're not doing that, okay, because the class will go much, much easier for you if you keep pace with me or if you're speeding ahead a little bit. Yeah, we could do space. Yeah, absolutely. I think that's a good one. So, or rugby. Rugby, that's very esoteric. Rugby's that sport, whenever it comes on, like on ESPN 12 or whatever, I always have to have someone explain it to me again. It's like, this is football, but not really, but, you know, less violent somehow, but more. I like space. Yeah, I think space is a good one. We'll do an astronomy one today. Because that's one of my, I don't know, I guess in another life I probably would have been an astronomer. But anyway, that's neither here nor there. So anyway, I'm glad that you guys are still engaged here. So just a couple announcements coming down the pipe. So apparently Pueblo County is going down in terms of the COVID terrorism color wheel, whatever. And so there's talk that is starting to boil up that we might be allowed to come back to campus a little bit earlier than we thought. So now it is my goal to get us some face-to-face time if you're interested in that. But understand that when I booked the class originally last fall when we built the schedule, I built it as a hybrid, okay? And I did so with the intent in mind that any type of face-to-face time that we have would be 100% optional, okay? And so if we do get going and we are allowed to come back, just a couple things. Number one, it works very much so like we do with the live streams here, but it would probably be much more me just directly asking you, what are you working on right now? And so if we do come back, I'm planning that we would come back on Wednesdays, wherever we meet. And I don't think we're in a computer lab, so you'd need to bring a laptop or something so that you could actually work on the Alex stuff in class. All right? With that being said, I still plan on doing the live streams on Mondays throughout the rest of the semester. And so if you don't feel the need to come in, if we're allowed to, that's absolutely fine. We'll still do the live streams. You can still ask me questions here on Mondays. And I'll still post all the videos, and I'll still, this, will be no different. It'll just be, you probably have the option of coming to class on Wednesdays. And that's if we get approval, all right? So my understanding is that they're not going to make any decisions on that for the next week or two, but already today there's like rumors going on and stuff. And so I just want to let you know 3 things. Number one, if we can have class time together, I will offer it. Number 2, if you don't want to come to that, that's fine. because you'll still be able to be here on the live streams on Monday. And number 3, yes, you can still complete the class 100% online if you so choose. All right, so I try and be as maximally flexible here as possible. But again, it is a math class, and so if you do need some face-to-face time, I will totally do that if we get the opportunity. All right, so for the meantime, Monday, Wednesday here on the live streams, at least for the next 2 weeks. Monday live streams here to the end of the semester. All right, and then I will keep you posted. All right, so no worries whatsoever. Other announcements? Yeah, no worries, Morgan. No worries. Yeah, my cats are all asleep at this point in time of day. You should have seen them the other day. I think I had a class on Saturday, or no, I had a class on Friday. And, you know, so I've got a bunch of toys back in the corner there, and they had trapped a little mouse back there. And so throughout the entire class, I was just waiting for my cats to try and murder this thing until I could get up and actually rescue him. Yeah, no, that's no problem. Anyway, other announcements. I just went through Alex and updated grades. And so in Blackboard here, it should show your current Alex score as of like 10 minutes ago on the mastery in your Pi. And so remember, in your Pi, you get mastery once you've taken what are they called? The little test, knowledge check. Once you've taken a little knowledge check, and then once I see that, and usually the way that it works from now on is like on Mondays, I'll just go through and update. So if you do work throughout the week, yeah, I won't post right away. But once I do my audits on Mondays, I'll give you 5 points for each topic that's mastered. All right. So there's 100 topics in the class. So that's 500. That's half your score in the entire class. So some of you are doing fantastic. All right. So just keep at the pace that you're at. Don't get behind. And at the same point in time, whenever you knock out a slice of your pie, like you do the orange slice and you got all the topics knocked out, go kill off all the quizzes. All right, that are associated with that. If you're ever curious about which ones go with which, just click on course modules here and it'll show you the chapters, all right, that are associated with each slice of your pie. So each one of these, of course, is a slice in your pie. All right, and so any questions on those, ping me, let me know, but I am keeping up on as far as grades. Where should you be in Alex? Right about here. So here's about the average for the class. So about 31, which makes sense. We're in week 4. It's about a third of the way through the class. So yeah, okay. So, well, not week 4 out of 16. So yeah, actually a little bit ahead if you're here. So that's great. And again, you know, there's 17 of them in this first one. Most of you probably knock these out in the first couple days. Okay. Make sure that you get through the oranges here by this week or next. And I'm on pace to finish the oranges here probably this week, if not today. No, we'll do it. It'll be this week. And then you're pushing into the reds by either next week or the following week at the latest, and you're absolutely fine. Just make sure that once you do one of these and you finish all your oranges, go take those 3 quizzes, all right? Or do them as you go. So, because like there's a frustrating thing when you work all the way through your pie and you're over here in the blues and all of a sudden you realize you get an orange quiz way back here and you jack it up like 4 or 5 times because you haven't done any of this stuff in a while. That gets a little frustrating. All right. So, you know, just make sure that you go through and knock out the quizzes once you finish each slice of your pie. And that way the class will just go, I mean, smooth as silk, all right? It's only like if you paint yourself into a corner, so if you disengage from the class for a couple weeks, things like that, that you start to, you know, get a little frustrated with it. And I notice who does that, and I'll start pinging you. It's like, hey, poke. You know? So, but again, also the class is designed to be, you know, fairly self-paced. And so, you know, I mean, I definitely see people who don't do anything until like late March and then just crush it all out. That I think that's really stressful. I'd prefer that you don't do it that way just because, you know, I'm concerned about your health. But if that's the way you want to do it, that's the way you can do it. All right. And likewise, a couple of you are on track definitely to finish the class early. And that's great too. Every single time I offer this class, there'll be, you know, 3 or 4 people out of a class of 20. Or maybe about 25 who, you know, they just rock it out and then they're done by spring break, you know. that's great too. Yeah, I mean, after that, fine. You did the work, you rode the channel like I asked you to, and so we're good. All right. So anyway, but yeah, this is about where you should be. So any other questions, just post them in there. Otherwise, I'm going to jump in here and let's take a look at my Pi. And you know what? I haven't looked at this since last week, so I'd be surprised. I wouldn't be surprised if it's going to try and chuck me into a knowledge check here, in which case you can watch me jack that up. No, not yet. So yeah, I'm almost all the way. I'm actually right where the class is at 31, so that's perfect. And so yeah, let's go ahead and kill off some more of these orange ones here today, because I think I wanted to talk about standard deviation, all right, which is an extremely important concept. It's something that you're going to be seeing a lot of in the future. Oh, I didn't finish this box and whisker plot. I'll do that one off camera. So I think I jacked it up enough on camera. You don't need to watch me struggle with it again. So, but these three right here are really, really important, okay, because they unlock a couple other ones. And understanding the concept behind standard deviation is really important. So you have two forms of statistics out there. We have measures of central tendency, and that's mean, median, and mode, okay? So I think we're all up to speed on that. The other statistic that's really important is standard deviation, which is how spread out your data is. It's like, so the concept behind it revolves around this thing called variance. And so variance is just how much difference is there between each one of your observations, okay? So, for example, if we took the height of everybody in the class, we'd notice that not everybody is the same height, but if they were all exactly the same height, we would have zero variance, which means our standard deviation would also be zero, okay? With variance, it's just the raw calculation of the differences between everybody. So I'm 5'8", you're 6'3". There's a 3-inch deviation there between you and me. All right, but in terms of statistics, we have multiple people in the entire class, and so we take the mean, okay, and then the deviation is the difference between your actual height and the class mean, okay. Standard deviation actually allows us to take that and take into consideration that some people are taller, some people are shorter, all right, and those two things do cancel each other out eventually if we get enough people in the data set. But, all right, so the difference between each individual person is still important, okay? And so we find a way using standard deviation to take those individual deviations, and what we basically do is we square them, all right, so that we capture the information that, yes, everybody's a little bit different. And then we actually take into consideration the entire mean, and we come up with with standard deviation, which is basically a measure of, on average, all right, how much does one person in height vary from the next, okay? So the calculation for it's really, really easy. Well, it's a pain in the butt, but it's an easy calculation. But really, it's the concept that's more important. I'm not going to force you to calculate the standard deviation by hand. After I think these two want you to do it, but I'm going to show you the fast way to do it anyway. And if you have a stats calculator, you can definitely use that, all right, to figure out sample standard deviation, population standard deviation. But the first problem that you should probably do is comparing standard deviations without calculation, all right? And this is where we see these infamous boxes. Again, notice that this one's different than the mean, where you're calculating means on these. Okay, because you only have 3 of them. You only have 3 to compare. You don't have 4. So actually, I think these problems are a lot easier. You can read the explanation. I don't think it's particularly good. I think it's easier just to eyeball these. Okay, so with the standard deviation, understand that the greater the standard deviation, the more spread out your data is. All right, smaller standard deviation, the more compact it is. And so it's asking us to put these in order based upon how spread out or how compact they are. All right, notice on each one of these, there's always going to be one blank column. All right, and so that's your middle values, okay, in this one. And then you're just going to count squares from the outside to find the one that is the lowest, all the way to the one which is the highest. So the most compact to the least compact, the least spread out to the most spread out, okay, whichever way you need to get there, okay. And so these are pretty straightforward. So take a look at this. All right, so this one I only have 2, 2. This one has 3, 3, 3, and 3, and that's all, you know, how many are apart are on either side of my blank column, which is 6 right here, okay? And so these two right here, B and C, are more compact than this one, okay? Because it has 3 values. This one just has 2 values next to that one. So this one is my least spread out, okay? or this one is my most spread out, so it's going to be my greatest value right there. Okay, and these two right here, same thing. We just have to look and see which one's next. All right. All right, so the next most spread out one, so we just have to count 3, 3, 1, 1. Okay, 3 is blank, 3 is blank, 2 is blank, 2 is not blank on this one. So this one is more compact than this one. So this one, C, is my most compact, leaving this one, B, as being the next. Check. All right, hope that makes sense. All right, so I think these they get a little bit more intuitive as you go through them. So let's do a couple more. Here we go. My blank column is 9 on each one of these. This one has 3, this one has 3, this one has 2. All right, so this one is my most spread out. And so bam, there we go. Now I just need to compare these two. This one has 3, this one has 3, this one has 1, this one has 2. So this one is more compact than this one, and so this one has a smaller standard deviation. Bam, and then this one, oops, not double A. Not talking about batteries here. And there we go, C. So B is next. Ta-da! Okay? Hope that makes sense. Let's do another one here real quick. All right? Now look at this guy right here. I don't think I've ever seen one like that. That's okay. All right, so 7 is my blank column. Notice this one has 2, this one has 2, this one 2 and 2. This one just has 1 on either side. So this one here is going to be my most spread out. Okay? Okay, so next after that, let's take a look at between these two. 5, so it's 7, 7, 6s, 2 6s, no 5, no 5. This one has a 4, this one has a 4, this one has a 3, this one has 2 3s. So this one is more compact, all right? And so this one is going to be my smallest standard deviation. Oops, no, jack that one up. There we go, pay attention to what you're doing. And then C, like that, check. Ta-da, 3 in a row, easy peasy. All right, keep it up. Let's see. Knowledge check time. Nope, not knowledge check time. Okay. All right, so we're going to cover these two here, but we need to find a trivia question here real quick. Let's do that. So we're going to do astronomy. Let's see what we got. Oh my gosh, there are tons of these out there. All right, so we're going to start with an easy one. All right, so there is a moon out there in the solar system called Titan. Titan orbits which planet? Which planet does the moon Titan orbit? Go. If you played Solar Quest, you know this one right off the bat. It's easy breezy. Actually, there's so many ways you can know this one. So, nope. Yes, Matt, you got it. It's Saturn. Correct. It's not Jupiter. It's Saturn. So, yes. Because Jupiter has, it has like 3 or 4 really big ones. But if I'm not mistaken, Titan's actually the largest moon in the solar system, if I'm not mistaken. Yeah, no, that's okay. It is Saturn. Yeah, you got it right there, Matt. All right, so you're eliminated for today. So, no, that's okay. No worries. Yeah, we'll ask another one here in a sec. So you were Johnny on the spot with the fingers there, so I think you're going to be just fine down the road. We'll do another one here in just a couple minutes. But let's actually talk about calculating sample and population standard deviations. Okay, now I'm not going to actually do this one, all right, this way. Okay, you can do it in the Alex calculator. It's actually pretty easy, but just understand that the difference. Okay, so what you're doing with these is you're actually using this formula here for sample standard deviation, and for population standard deviation right here you use a slightly different formula. Okay, notice that this one doesn't have necessarily the entire square root thing, but if you look at this, it's really not that difficult to understand. It's just I mean, it's just ugly to do these by hand, because what you have to do is you have to take the observation x1, so that would be your first observation up here, 34, subtract the mean. All right, so you have to calculate the mean of all these things, square that, all right, and then do the same for the next observation, the next observation, the next observation, and then that all over n, all right, which is the number in your sample, and then the square root of the entire thing. That gives you your sample standard deviation. Let me just walk you through it on the calculator here real quick so you can kind of see how that works. So you take your first, well, actually the very first thing you need to do is calculate the mean. So send all the data to the calculator like this. And then, oh my God, they took away our mean button. There's usually a mean button right here, which is X bar. Okay, lame. So, but anyway, you can still get around that by doing sum, send the data to the calculator, enter, and then divide it by how many there are. There are 6. And so my mean on this one is 40. Okay? And then you'd have to punch them in each individually like here. So it'd be like this. 34 minus 40, end parentheses, square that, add your next one, which would be 38 minus 40, end parentheses, square that. Oh, no, not that one. That's chi-square. My bad. This one. No. Oh, actually, you got a sum of squares. No, it's easier to do it this way. Never mind. So square that, and then plus, and then whatever your next value is. I don't know why I got that little thing in there. Anyway, there we go. 32 minus 40, end parenthesis, square that, plus, next one is 31 minus 40, end parentheses, square that, okay, plus, open parentheses, 53 minus 40, square that, oh, not to that, square that, plus 52 minus 40, end parentheses, square that, okay, and then you grab all this stuff and then divide it by 6, and then you grab the whole thing again like that and do the square root of it so it looks exactly, oh no, I didn't grab them all, see, look at that. Let's go in here. You got to be really careful with the Alex calculator. So don't quite have them all. So let's make sure we grab them all. If it'll let me. Come on, man. You silly, silly thing, you. I think if you use your arrow keys. Well, whatever, man. Oh my gosh. Come on. I don't have a select all. No, for some reason I got a break in there somehow. So I'd have to do this all again, but screw that. Right? You just take the entire thing, divide it by 6, okay, and then grab the entire thing like that, do your square root. All right, I don't have all of it in there and I can't figure it out because I don't have the patience. And then hit enter and bam, you'd get your standard deviation right there, okay? Later on it's going to give you a button that'll do that all for you, okay? And that's for population standard deviation. All right, so you can do them that way. All right, it is technically possible to do them in the Alex calculator. It's obviously not very much fun. So the best way to do these, okay, is to actually use a calculator that does this stuff for you. Okay, so you go over to course modules here, descriptive statistics, and here we go. Here's a standard deviation calculator. You can use this one right here. I think this is calculator.net, and all you have to do is actually just punch the numbers in and make sure you hit either population or sample on these. And I think you might be able to copy these. Control C, and bam, there we go. All right, so, oh, well, look at that. Sneaky, sneaky punks there. Change those to semicolons. So you just go in here and change them all back to commas. And now you're good. Like that. Calculate, and ta-da, does it for you. All right. So let's see. This is population. Oh, I hope I hit the right one. Make sure you're doing the right one. This is sample. Oops. No, it was population. There we go. Calculate. And so you can just punch it in there. 7.047. How many? 2 decimal places. 7.47, right? Or is it 0.47? 0.47. So 0.5. There we go. Checkez-vous. Correct? Yeah, no worries. No problems, Squidson. So you can do them this way. All right, it's pretty straightforward. Let's just do another one, and then I'll show you how to do it a little bit different in the sample one. So pull up your calculator, clear that out, copy all the data, give me a Control C, go back over to the standard deviation calculator, and this is exactly what you would do if you had a stats calculator. So you would actually, there's a function key for this, and then you would just punch in the data for each one, okay? And it's doing all the calculations for you in terms of like the 6.38, in terms of figuring out the deviation for each individual item, okay? Squaring those. Oh, what did I do wrong? Oh my gosh, yeah. Arg. Somebody, dyslexia kicking in there. Boo. So let's try another one here. And then what it would do for you is the exact same thing that this website here does. This website does work pretty well. I've never seen this one go down, but I guarantee you there's a million calculators out there that you can use. All right, and maybe you wouldn't have to do this onerous thing here where you have to change these back to commas rather than semicolons. At least I think you have to do that. Maybe not. Let's try it. 1.29. 1.29. And notice your standard deviation is always going to be smaller than the values in your data set. Okay, so that's important to understand too. If you get something that's really weird, you jacked it up. Or you've got one outlier in here that's just way off. All right, so, but it should always fit in between your data. So take a look between these 10, 9, 8, 6, 7. Yeah, about 1.29 would be the average difference between all of those. That's exactly what standard deviation is. Okay, so let's do another one here. And, you know, we could talk about the differences between population and sample here real quick. Just understand that a sample, okay, is just a piece that's taken from a population. It's not the entire population itself. So, for example, if we did, like, the height of everybody in the class, that would be our population, okay? But if we decided to just take the height of every junior in our class, that would be a sample from the population, okay? And so the calculation is slightly different between the two. The reason why that becomes important will become more apparent as we go further in the class, all right? So don't worry about it too much right now. Let me just kill this one off here. Let's go back to this. And like I said, this is kind of the easy way to do these. But in the real world, we would never ask you to actually calculate sample standard deviation or population standard deviation by hand, just because there's too many, it's too important of a statistic, 8.41, and there would be too many opportunities to jack it up. All right, so like one little miscalculation in this could ruin your entire analysis. And so that's why we use Microsoft Excel or something like that to do it, which is, what did I do? Oh my gosh, what did I get wrong here? How frustrating. 8.41. Did I do 8.14? Oh my God. You guys watched me do that too, didn't you? So, all right. Let's murder this problem off. Come on, man. So, here we go. Copy it. And then go back over here. Paste it in there. I wonder if it works with the semicolons. Let's see. No. Yeah. No. Doesn't like these semicolons. That's okay. These are pretty easy to kill off. So, I mean, you certainly wouldn't want to do this if you had a data set that had, you know, a million observations in it. So, 2.10. 2.10. There we go. Checkez-vous. Dunzo. Thank you. All right. So that's sample. Or no, that was population standard deviation. Let me show you sample standard deviation here real quick. I'm going to show you an alternate way to do these. All right. So sample standard deviation is exactly the same. Just understand that it's got a slight change in the formula. All right. In the formula, the change is going to be that we're now going to use our n minus 1. Okay. So we're going to take one observation out of our sample standard deviation. Of our sample size, and this here, all right, in the future will be known as degrees of freedom. All right, degrees of freedom is very, very important, but the thing that you need to understand about it right now is that degrees of freedom only applies when you're dealing with a sample. Okay, and so all the formulas will be slightly different from population, from sample, because of the fact that you need to have you need to account for degrees of freedom. Now we could go into theoretically why that is, but the way that I want you to think about it, the most simple way to think about it, is since you're dealing with a sample, you need to give yourself a little bit of wiggle room. Okay, and so by removing one of the observations from the sample, okay, so in terms of our calculations, we don't actually take one of these out. It's just when we actually do the n on this, we take one of the observations out of there. That does give us just a little bit of more freedom when we're dealing with a sample as opposed to a population. That's a very basic explanation of it, but that's how I want you to think about it, because it does make your life a little bit easier. All right, and so I'm going to actually do something a little bit different with this one. We'll actually use Microsoft Excel, all right, to do these. And so here's my observations. Oh, it doesn't say send these to the calculator in this one. I wonder why that is. Boo. Can I actually just click on these and drag over? No, lame. That's new. Man, some teachers out there probably complained. You know, they said, oh, we want to make sure people can do these by hand, blah, 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 boo. If you had a calculator, you just punch these in. We're just going to do it in Microsoft Excel. So let me show you how easy that is to do. So get over to your Excel. If you don't have Excel, you need to get Excel. It's free through the school. Just do the things. Okay, I hope you can see this. All right, so, but basically, I just need to do a little data entry here. So 11, enter 6, 11, 6, 10, 4, 12, 11. If you have any experience with 10 key, it makes life way easier. Okay? And so let's just double check these. 11, 6, 10, 4, 12, and 11. Okay? So in order to actually get my sample standard deviation, okay, I can do this with a simple formula. And every formula in Excel starts with equals. And then you just type in ST and ta-da, it brings up a list of formulas. So these are your two formulas right here for standard deviation. You can do it for population. So that's this one, stdev.p or stdev.s. Obviously that one's for sample, so double click that. Grab your data, okay. Close parenthesis, enter. Ta-da, there's my sample standard deviation for this data set right here. And so, what was it, 3.2? Look at this. Even in Excel, you can do this really cool thing where you just hit this button here, and it rounds it for you. It's 3.22. So, well, actually, that might not be... Oh, yeah. All right, let's try it. I didn't know if that previous number was a 5. Or not. No. All right, we're good. So you can do it this way as well. So I find Excel to be a little bit easier. And here's the thing is once you have a spreadsheet up and you've already got that formula in here, now all I have to do is change the numbers. So 49, 58, 48, 48, 68, 67. This one's blank, so just hit space and off it's gone. So because this one only has 5 rather than 6, but there's my sample standard deviation for this one, 9.51. Check. Ta-da! Let's do one more. And again, since I'm using Microsoft Excel, I don't have to punch all the stuff in there again. All I have to do is change the data. So 32, 25, 23, 21, 28, and 39. There we go, 6.63. 6.63. Easy breezy. Dunzo. So there are things that you're going to want to use Microsoft Excel for in this class in the future. It's just going to make your life a little bit easier. So get familiar with Microsoft Excel. And I know you've all had that, like, you know, welcome to college. These are Microsoft. I mean, you guys have seen this stuff in high school. It's been around that long, you know. So I'm sure that you've got some experience using Excel. But just understand that out there in the wild, when we're doing statistical analysis, Excel is one of our favorite tools. There are more advanced statistics packages out there that will do all this stuff for you with basically the stroke of the click of a couple buttons. All right, and that's how we do it in the wild. Okay, so in Dr. Holman's class, the advanced class and things like that, he's going to start introducing you to some of those programs out there. Or if you've had other stats class in the past, you might have been exposed to a program called R, or there's another one called Stata. I don't think any of you would probably see SPSS just quite yet because it's really expensive. But those are all statistical packages that data analysts use across the world. And it's basically, they're just really fancy versions of Excel. Excel will do everything just about. Sometimes you have to massage it a little bit, but it'll do most of the things that you want it to do. And for the purposes of this class, there are times where, yes, using Excel is way easier, so feel free. Okay? All right. Oh, yeah, I can show you how to do the Excel formula one more time. No problem. Sorry if I was going a little fast there. Let's go back to a review tab in here. And I will do that for sample. For population. So let's go descriptives. Population standard deviation. So here we go. So bring up your Excel. Okay, ta-da. Okay, new tab. All right. And so let's do the data entry first. So now most of these have 5 or 6. All right, so you want to give yourself just a little bit of room. So let's do our data entry, 11, 11, 5, 6, and 2. I'm going to give myself an extra one there just because the next problem will probably have 6, or you could do 7 or 8, whatever, doesn't matter. And then just to start any Excel formula, you hit equals. Okay, and then you type in, like, usually you're going to kind of know what it is, what it's asking for. So if I wanted like average, I would start typing average, and there he goes. It's going to start bringing up those. But for standard deviation, of course, it's standard, ST. Okay, so standard deviation, it's these two formulas right here, STDEV.P. So I'm looking for population, so I'd use this one. If I was looking for sample, I'd use the second one, which is STDEV.S. Just double click that, and it already gives you an open parenthesis. And Excel will always tell you what it's looking for next. So here's the formula, and here's what it's looking for next. And so it's looking for my data. So just click, drag, hit enter, bam, you're donezo. Okay, so, and if you want to change this so it's down to like, 2, so always check this, here where it says round your answer to 2. Excel will even do the rounding for you. You just change it down to 2. So 3.52, and you can just punch that in directly like that. Bam. There you go. Hope that helps. All right. Squids, yeah, you wanted to know where we should be in the class. You should be on pace with me. All right, so which is, let me go back to my pie. Here we go. About here. So 30-ish topics. Yeah, you're in great shape. And I mean, you might not have like all the yellows done. You might have 1 or 2 left. Go kill them off. Same thing. You might not have all the oranges done. You might have a couple of these reds and stuff. I'm just doing things in order, okay? So, and honestly, this is the first time I've done this, because in the past, sometimes I just like take whatever Alex gives me. And actually, there's a lot more, like, I feel a lot like more chill about like my progress, because I wanted to see most people have this orange one done by this week or next. All right, and then make sure that you're working on the reds, next week and the following. All right, so because some of the stuff that we get down here, it'll take you a day to do, like, well, not a day, but like a live stream session to actually get just one of the problems knocked out, because they can be a pain. So I'm not trying to make these look too easy here. All right. Space trivia. In the meantime, questions, topics that you're jammed up on. It's time to start punching them in there. Yeah, you're in a great spot. So that's awesome. You're right on pace. So if you want to push ahead a little bit, it'll pay dividends down the road. If you want to take it easy this week, that's fine too. Just make sure you're not forgetting about the quizzes. All right. So if you get all your oranges knocked out, go do your quizzes. So, and remember, go in here, of course, modules. So module 1, descriptives, orange. Okay, chapters 1 through 3. So go knock out those. Okay. Anyway, yeah, all right. So I've got too many dang windows up here, so let's murder some of these off. And here we go. So space trivia, more space trivia. Oh, here's a great one. Okay, so not only is this a space trivia question, this is also a video game trivia question. So Phobos and Deimos are the moons of which planet? So which planet has 2 moons known as Phobos and Deimos? Go for it. Come on, man. You shouldn't have to Google this one, considering our discussion, earlier today. Phobos and Deimos. So, which one? Which planet to which planet do they orbit? Good job, Squidson. You got it. It is Mars. All right. So it is Mars. All right. So, and you probably visited both at some point in time in your video gaming career and murdered many demons there. So, or you watched that really bad movie with Dwayne "The Rock" Johnson. And who else was in that? I think that was one of Carl Urban's very first movies, if I'm not mistaken. Yeah, and then gosh, there was somebody else who's really silly famous in that one. Down the road, I can't remember. No, 1000%. Yeah, exactly. I know. So I've been there many times, both in life and on the YouTubes, watching people speed run. Yeah. So, all right, we'll do more here in just a minute. So, in the meantime, any questions on anything in this? Because I think I am down to just a couple left here in the oranges. And I mean, we can start pushing into some of the reds if you're curious about that. Otherwise, I'm going to talk about this one right here, which is Chebyshev's theorem and the empirical rule, because I think, yeah, so I've got 2 left on this one. And how many topics are in? Hang on. The orange. So the orange is 19. So yeah, those are the only 2 that I have left in the orange. So do you guys want me to talk about Chebyshev? It takes a few minutes to do. But it might be one that you ran into and you got a little jammed up on. Otherwise, we can spend all day Wednesday on it. So I'm going to kind of leave that one up to you. So punch it into the comments there. Or I'll go fight with Box and Whisker, or I'll do whatever you want me to do. So let's just put it that way. So punch it into the box there. What do you mean by sure? So Lexi, you want to do Chebyshev? So say yes for Chebyshev, or if you don't want to do that one today, we'll do it on Wednesday. It's fine. It's an evolving problem. So. And it does take some time. So, but if you got the vote for it, then yeah, we'll do it. Box and Whisker? Okay. Yep. Let's go jack up Box and Whisker again. Sounds good. So, if you want to take a stab at the Chebyshev one, though, go over here, Course Modules, Descriptive Statistics, download this calculator, okay? Download this calculator. Yeah, download this calculator. It will help you with half the problems on Chebyshev. All right, so but like I said, it's a little bit of an involving topic, so I almost always spend an entire day on that one, and so we'll save that one for Wednesday. But if you have one that's further down the road that you want me to cover here real quick today, that's fine too. Just punch it in there. But yeah, let's do Box and Whisker, just because I jacked it up and it's kind of a pain. All right, start my path. Here we go. Let's see if it just barfs it out at me. No, not yet. So Venn diagrams, blah 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 blah. Chebyshev. No, actually, it's got to be in here somewhere. There we go. Box and Whisker plots. All right, so Box and Whisker, pretty straightforward. You've got this data here, and you've got to enter, you got to manipulate this graph so that it reflects the distribution of the data. So think of this as kind of like a histogram, all right, but it's just a way where we can actually just do a little diagram like this and get a really good idea of the distribution of the data right off the bat. Now, this is the only problem in Alex for a long time. There will be some more down the road where you'll be dealing with median rather than mean, okay? And so median is the key here, and then setting these up so that each one of them is in the right spot really helps. And actually, you can use the percentile format to figure out some of these too. But this one's pretty straightforward. Notice we got a number line down here that goes from least to greatest, okay? And so this dot here is going to represent our maximum value. This one here is going to represent our minimum value. So that's the part you always do first. So take your data, send it to the calculator, hit sort, and look for your highest value, which is 29, and your lowest, which is 5 in this case. So I take my lowest, take it all the way down to 5, take my highest, take it up to 29. Notice that it goes up to 30, so you can't just always snap this all the way to the end. All right, so that's just Alex making sure that you're paying attention. All right, and then so the next thing is to find the median of the data. All right, and so the median is your middle value, and since I have 16 in here, we split 16 in half to 8. Okay. And so 1, 2, 3, 4, 5, 6, 7, 8 up from the bottom. But I also have 1, 2, 3, 4, 5, 6, 7, 8 from the top. So my middle value is actually right in between here, 17 and 18, which is going to be 17.5. Okay, and so that's this middle line right here. That's your median. Now this value and this value, this is your first quartile and this is your second quartile. All right, so 2 different ways to do these. All right, one is you can count. All right, so I've got 8 numbers on this side between here and here, and so it would be number 4, right? Or 5. See, that's the part that I always jack up. And so the other way that to do this is to just think about it. All right, so it's a 25th percentile. So I have 16 numbers in here. I can just take 25th percentile, multiply it by 16. okay, it's going to be number 4 in this. All right, and so let me go back here and send the data to the calculator and sort this. All right, so it's going to be number 4. 1, 2, 3, 4. That guy right there. So I could just take it and put this one at 10. Likewise, this is my 75th percentile, so I can just take .75 and multiply that by my n, which is 16 right there. It's going to be number 12, okay? And so just take the data, put it back in the calculator, sort it out, okay? Number 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24. Give me that guy right there. Check. And maximum is not correct. Oh my gosh, look at that. I jacked that up. First quartile is not correct. Why is that? So .25. See, these are frustrating. And they are another 16. It's 4. Should be my 4th number. Unless it's looking for my 5th. Wait a minute. Let me calculator. Sort 4th number. 1, 2, 3, 4. Did I jack that up? 10. Maybe it's my 5th number. Let's try this. Which would be 12. Recheck. No, got that one wrong too. Dang it, now I gotta go look at the explanation. So, is it 4.5? So let's see. Finding the first quartile. How do they want us to do this? First quartile is the median after the data. So, lower half, 8 values. Let's say 8 is the even number. There are 2 values in the middle. Okay, yeah, so that would be 11. All right, so they're being picky on this one. All right, so see, and that's the easier way to do these is actually on a number line, but I don't want to get out paper because I'm lazy and write them all out. So, but yeah, see, so like the first one I figured out is 8 and 8 on each side. So this one's 8, this one's 8. The reason why we got this one right was because 24 had 2 values in there and it split the difference between the two. All right. So let's do it the way that they want us to do it here, just because, you know, like sometimes Alex does trip you up on these things. All right, so here we go. Here's our data. Interviewed 18, so students from 18 colleges, okay? And so this one will be different, okay? So let's walk through it really carefully. Let's take the data, send it to the calculator, hit the sort button here. 53 is our highest, 25 is our lowest. So let's do this right. 53 is our highest. And what was our lowest? 25 is our lowest. All the way down, 25. Okay. So now we have 18. Okay, so 18 is an even number, so split it in half. So it's going to be between numbers 9 and 10. All right, so there's going to be 9 on each side. So here we go, sort just in case, and we're going to count up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 38, 10, 39. So it's going to be 38.5. So right there. Okay, now notice we have 9 numbers on each side. The middle value on those, since 9 is an odd number, has 4 on one side, 4 on the other side, so it's our 5th number right in the middle, okay, for this first one. 1, 2, 3, 4, 5, it's 33. And then on this side, same thing, all right? We got 9 on that side. Okay, so it's 4 and 4, with our 5th from the highest, all right, being our third quartile. So 1, 2, 3, 4, 5, 47. So there we go. All right, I hope that makes sense. All right, so, but, you know, maybe your fingers help more than anything else. I thought we could use the formula to figure out the percentile, but yeah, when you have multiple values that are the same in the same row, it does jack that up a little bit. So here we go. Check. There we go. Let's try another one. Let's kill this problem off here and just make it go away forever. So send the data to the calculator. Highest value, sort, is going to be 82, and lowest is 50. So 50, 50, and 82, which is right there. So we have 17, okay? And so 17 split in half, since it's an odd number, The closest even number that we have is 16, so it's going to be 8 on one side, 8 on the other side, so it's going to be our 9th value. So you have 8, 9, and then 8 more gives us 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 69. 69 is our median, okay? All right, now we have 8 numbers on either side here. I just moved that, didn't I? Ooh, be careful with that. So I have 8 numbers on this side here. So 8 splits evenly into 4 and 4. So it's 4 from the top. It's between that 4th and that 5th one. Okay, so here we go. 1, 2, 3, 4. And here's our 5th number. Notice that they're the same, 78. And so this one here is going to be 78 as well. Okay, same thing from the bottom. 1, 2, 3, 4. Here's our 5th number. It's between these two, so 60, 61 is going to be 60.5. Okay, check. Okay, cool. Yes, thanks. So I'm glad you're getting the hang of these. So you can sit here and watch me jack them up on the YouTube in front of God and everybody. That's wonderful. That's all right. So here we go. 19 cities. Send it to the calculator. Sort. So my highest is 40. My lowest is 10. So 10 all the way down. Highest is 40, which is all the way up. Cool. All right. So 19. Closest even number is 18. So that'd be 9 on either side. And so it's my 10th number. 1, 2, 3, 4, 5, 6, 7, 8. Oh, gosh dang it. I wish you could expand this calculator out. That's like the one thing, you know, that Alex just, I mean, you should be able to grab this edge here and just blow it up a little bit. They won't let you do it. So anyway, 10th number, right? Yeah, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be 27. Bam. There we go. All right, so let's see. That leaves me with 9 on either side, okay, with the 10th number in the middle. Yes, okay. So it'll be my 5th number from the bottom, so because 9, all right, is 4 and 4 with the 5th in the middle. So 1, 2, 3, 4, 5, 19 on this one, right there. And same thing, 5th from the top. Did I screw that one? Did I screw that up? 1, 2, 3, 4, 5, 19, 19. Okay. And then 5th from the top. 1, 2, 3, 4, 5, 34. All right, there we go. Check. Done. Yeah, murdered that problem. Be gone with you. All right. So, yeah, that leaves me with just Chevy Chev. All right. And, oh, no, actually, we got a new one here. Mean median mode comparisons. Really? Maybe I didn't do that one. Okay, so that actually opens up a new one. We can do that one here real quick. What time is it? We're not quite at the hour mark. Yeah, let's do this one real quick. All right, so, and then we'll save this one for Wednesday. Man, I thought I had all but 2 of these done. So that's interesting that it opened up another one there. Yeah, okay, this problem sucks. Okay, if you've seen this one before, it does get a little confusing because there are a lot of different ways in which they actually explain this to you. All right, and so, oh man, I'm really tempted to leave this one for Wednesday now. So, yeah, now let's do it. Okay, so it'll only take a few minutes. But I don't mind explaining this one again if I have to. Now, on this one, you don't have to do any, like, real big comparisons. You just have to understand there's no math that you have to do in these problems. They're all logic, all right? There's hacks for this one that I will teach you here today because each one of these sets down here is going to ask you a series of questions. And then it's going to actually ask you to make a conclusion down here on, you know, whether the mean or the median is usually greater, which can be really confusing. So here we go. Let's just dive right into it. All right. Guadalajara tourist daily sightly seen as trip capacity of 55 people. Each day, tour officials record the number of people making the trip. Data for a section of 21 summer days follows as follows. And so this is our data distribution here. Notice that it's in order. Okay, that's pretty handy. Okay, and then it gives us our histogram here. All right, so it's just frequency, not relative frequency. Okay, and so now you have to answer questions on these. And so basically what it's doing in these problems is trying to get you used to taking a look at data distribution and making inferences on those. Okay, so because when you get data that looks funky like this, all right, so this is heavily positively skewed data, or no, this is negatively skewed data. All right, so tail always points towards the skew. Okay, and so our mean and our median are going to be different from each other. All right, when data is symmetrical, your mean and your median are pretty dang close to each other. But when it gets like this, it's a little screwy. All right, and so for these data, which measures of central tendency take more one value? Mean never takes more than one value because remember, it's a calculated statistic. You add up all the values and then you divide them by how many of them there are. Okay, so there's only ever going to be one mean. The same thing is true of medians. So never ever check this, never ever check that. Don't do that. In fact, uncheck those. The question is whether or not the data has more than one mode. Data can always have more than one mode. You can have bimodal data where it has two modes. You can have multimodal data where it has way more than two modes. It's not very common, but it does happen. Or you can have what's called non-modal data where it doesn't have a mode, meaning that none of the values ever repeat themselves in the observations. This one, we just have to take a look and see what the mode is. And thank God they put these in order. So I can see here's a mode right here, 1. Okay, 49. Here's another one, 53. So 1, 2, 3, 53s, 1, 2, 3, 52s, 1, 2, 3, 49s. So this data definitely has more than one mode. Okay, remember, mode is whichever one occurs the most. Since we have a three-way tie, this one does have more than one value, and so we would click that box. The crazy thing about these problems is sometimes it is none of the above. All right, so you just got to watch out for those. All right, suppose that the measurement 32, the smallest measurement in the data set, were replaced by 16. So we're going to take this one, chop that out. What would change? Automatically, your mean would change. You almost always check this one. Yeah, oh no, for this part B right here, okay? Because if I change any of the observations in the data set, my mean is going to change, even though it's just going to be a little tweak. All right, so it might be like rounded out to the 8th decimal. You never know, but it would change. Okay, so the question is whether or not the median or the mode changes. Well, if we have the same number of observations in the data set, meaning that we're not eliminating any of these, then your median never changes. Okay, so do not check this one for part B, okay, because in this one it's always going to be replacement. We're going to replace something with else, and that means your median stays right the same. It's the middle value. The mode might change. So if 38 was in our mode, okay, so say like we had, you know, I like 5 32s here, and if we changed one with the 16, yeah, it might change my mode. So just check and say, hey, is that actually number that we're actually changing here? If that's my mode, then yeah, it might change. Just double check it, okay? And so, but this one, it's always check this one, never check this one, maybe check this one. All right, so next problem here, suppose that starting with the original data set, the smallest measurement were removed. So we're just going to murder this number off here. Mean would automatically change. My median would change as well, maybe. Okay, this is where you have to check your median, okay? So my median, 21 summer days, so 21 closest, next lowest round number is 20, split into 10, and so my median is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's this 11th number, and notice that if we actually chop that bottom one out, my median would actually change to here. Okay, but it's between two numbers that are exactly the same, and so my median would actually not change in this one. That is some sneaky BS that they pull in this problem here. Watch for it. So the trick on this one is always check to see if your median would actually fall somewhere in here, and if there's a mode in there, meaning that one that repeats multiple times, then your median would probably not change. If there's no mode in there, your median's going to change. All right, Blah, hope that helps. Okay, next one here. This one's usually pretty easy. So which of the following best describes the distribution of the original data? Negative skewed, positive skew, or roughly symmetrical? Symmetrical looks like a bell. Okay, you're going to get used to that a lot here in the future. But the skew, the trick behind skew is always remember the tail points towards the skew. And since this one has a tail that's pointing to the left or the lower values, this one is negatively skewed. Okay, if the tail was pointing this way, it'd be positively skewed, so pointing towards the higher values, then yeah, it would be positively skewed. So there we go. Check. Those are not fun. Okay, so let's do another one here, and I'll save more of these for next time, so because it does get a little bit difficult. Here's one. So this is roughly symmetrical. Okay, all right, and so let's just go through them. Part A, which measure of central tendency do not exist? The only one that we have to check is mode. So is there a mode in here? There's a mode, 58, 58, 63, 63. Okay, so this is one of these, yes. So we actually have a mean, a median. We always have those. The question is whether or not we have a mode. We have two modes. We have 63s and 58. So always check for that. And so if you do have a mode, click this one, which is none. All right. Next, suppose the measurement 14, the smallest one, were replaced by 5. All right, so my mean is automatically changed. My median is not going to change. This is nowhere near my modes, so that doesn't matter either. The only thing that would change is mean. Next one, suppose the original data set, largest measurement. So this one, we're going to kill off that 90. Mean would change. Now the next thing is my median. Would my median change? So there's 24. Okay, so my median is at 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if I remove that one, so it'd be at 12 and a half. So my median right now is right between these two. If I kill that value off, my median would change down to this 48. So yeah, that one would change. Okay, mode. Nope, my mode's nowhere near here, so I can't check that one. Best describes the distribution of the data. It is roughly symmetrical. Notice that it is bell-shaped. Okay, so if it doesn't have a tail that points, clearly in one direction or the other, it is roughly symmetrical. There we go. Check. Ooh, all right, fun stuff. Okay, we'll save another one for Wednesday there, so you can have a little review problem on this one. Okay. In the meantime, let me know if you're jammed up on anything. If there's anything specifically you want me to cover on Wednesday, I will be happy to do so. But we will definitely do Chevy Chev, and we'll come back to this mean one right here, because this is a problem that a lot of people get jammed up on. So if you get a little frustrated with it, don't feel bad. Okay, so it's one of the more challenging problems in the orange piece. And I had almost forgotten about it. I thought we almost got off the hook with it. All right, but we're at the hour mark here, so let's do a trivia question and call it quits. Let's see. Oh man, we've asked a lot of moon questions. These are actually really good. So, all right, so there's 2 answers for this one. I will give you credit for either one of them. All right, but you got to get it up there first. Which planets have no moons? There are 2. All right. I will give you credit for one of those, all right? So which planet have no moons? There are 2 planets that have no moons. Which ones are they? And no, it's not Pluto, okay? Yes, Venus is one. Yes, good. Good, so you got that one. So what's the other one? Someone throw up the other one. So, yeah, Aiden, get in there. What's the other one? Yes, good. You got it, Aiden. Yes, it's Mercury. It's Venus and Mercury. So good job. So Guts and Aiden, you got credit on that one today. So email me. Let me know what chapter quiz you'd like off, and I will be happy to oblige you. Astronomy's fun. We're gonna have to do some more astronomy in the future. I know, Lexi, you got him. He's just a little slow on the fingers there. You almost did say Pluto. I don't know. I mean, Pluto is. I don't know. I mean, how many of you have read what was it? Neil deGrasse Tyson had that great book. It was like not necessarily, astronomy for dummies, but essentially it was. I think it was like The Cosmos for the Common Man or something like that. I don't know. It was really good. But that's the one where, he's the one who got all involved in the Pluto thing. And isn't there supposed to be like another exoplanet way out there that, so there might actually be more planets in the solar system than we're aware of? or something like that. But you know, Pluto kind of goes back and forth. I don't know. So, when I was growing up, it was definitively a planet. You know? No, I was like, no, it's not a planet. It's not big enough to be a planet. So I don't know. Astrophysics for People in a Hurry. Yes, it's an excellent book. So if you like this stuff at all, it's really short. It's on Audible. It'll take you like 3 drives to work to actually get through it. Well, it depends on how far your work is, but still at the same point in time, it's really, really cool book. And then his whole series is great. And then, you know, he pops up on all the major podcasts from time to time. Shoot, I think he's been on Rogan like 5 times or something like that. And so, you know, it's just kind of, it's interesting to engage with you know, a different body of knowledge, one that you don't necessarily know that much about. And when you have someone who does know a lot about it and is willing to explain it to you, it's really cool. So I hope I can do that with stats. So anyway, all right. So we're donezo for the day. Feel free to log off here if you don't have any questions. Otherwise, I'll stick around for another minute or two, just in case you have any questions, comments, concerns. But enjoy the afternoon. So it's actually looking pretty nice out there. I'm thinking about getting out of here myself. And so, you know, get out there while you can. But at the same point in time, we'll be back here on Wednesday, and I'll walk you through that monstrous problem known as Chebyshev's theorem. So we will get through it and absolutely kill that one off. All right. So with that being said, have a good afternoon. We'll catch you all on Wednesday, and like I said, I'll stick around here for a sec just in case you have anything. All right. If not, take care. See ya. It's a great book. Yeah, it's really easy to read too, Lexi. It's kind of neat, and there are some things in there that, I mean, once you start getting into the theoretical piece, it's just mind blowing. So, you bet, Morgan. Take care. You bet, Lexi. Enjoy that book. It's a good read. It's a really good read. Yeah. If I had a copy of it, I'd give it to you. But it's right here on my phone. All right, about 30 seconds. Got any questions? Punch them in. All right, 10 seconds. 5, 4, 3, 2, 1. See ya. See you Wednesday.